To multiply fractions, you multiply the numerators and multiply the denominators, and then try to reduce. An alternative strategy is that if you notice before you take the product that you have a common factor in the numerator and denominator, say in the numerator of one fraction and the denominator of the other, you can reduce first before you multiply. For example, suppose we have 3 over 4 times 8 over 9. 3 and 9 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. 8 and 4 are both divisible by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Now on the top we have 1 times 2, which is 2. On the bottom we have 1 times 3, which is 3. And we end up with 2/3. When you're dividing fractions, you leave the first fraction alone, change the problem to multiplication, and take the reciprocal of the second fraction by flipping it. In this case, we don't have any common factors in the numerator and denominator. We just multiply the numerators. 3 times 9 would be 27. In the denominator, 4 times 8 would be 32. And that would be the answer in lowest terms. Let's take a look at our next problem. Here we have negative 7x squared over 5y times 3y to the 5th over 14x squared. You could go through the process of multiplying and then reducing, or as in the example above, you can reduce first and then multiply, whichever way you find easier. What I've often found is that when my fractions only have one term in the numerator and one term in the denominator, in that case, I find it easier to multiply first and then reduce. For example, here, negative 7x squared times 3y to the 5th, negative 7 times 3 is negative 21, and we have negative 21x squared y to the 5th. In the denominator, 5 times 14 is 70, and we have 70x squared y, which I'm going to go ahead and write as y to the 1st. Now, when we're reducing this to lowest terms, negative 21 and 70 are both divisible by 7. Negative 21 divided by 7 is negative 3. 70 divided by 7 is 10. X squared and x squared, being the exact same power of x, cancel each other out when we divide. Y to the 5th divided by y to the 1st, we subtract the smaller exponent from the larger exponent, and we would have y to the 4th remaining in our numerator. So negative 3y to the 4th over 10 is our solution. Now, in contrast, what I've found when I don't just have one term on the top and bottom of each fraction is that in cases such as this next problem, it's easier to factor all the parts and then reduce before multiplying. For example, x squared plus x, I can factor out an x, and that would be x times x plus 1. In the denominator, I have 3x. I can't factor the top of the next one, it's just 6. In the denominator of the second fraction, I can factor out a 5. I would be left with 5 times x plus 1. And now we've got a few things we can do to reduce it. There's an x plus 1 on the top of one fraction and the bottom of the other. We also, in the first fraction, have an x in the numerator and the denominator. One other thing we can do is to notice that 6 and 3 are both divisible by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. All that remains in the numerator is 2. In the denominator, we're left with 1 times 5, which is 5. So 2/5 is our answer. Let's try this process for our next problem. So to factor 3x plus 3, we could factor out a greatest common factor of 3. And we would have 3 times x plus 1. In the denominator, we could factor out a greatest common factor of 5x. 5x, when we factor out 5x, we're left with 1. Minus 5x squared, when we factor out a 5x, we're left with minus x. And then times. Now in the numerator, this is one that's a little bit more complicated to factor. It starts with 2x squared, so we'll have 2x and x. Now there's not that many options for 3. It's either 1 and 3 or 3 and 1. We do also have to consider that it's a negative 3, so 1's going to be positive and 1's going to be negative. To get the right combination here, we would need a 3 here, a 1 here, a plus here, and a minus here. If you take the time to work this out by trial and error or by the step-by-step process that we discussed when we were going over factoring, you would see that this is the result. In the denominator, we have a difference of squares. The square root of 4x squared is 2x, so we put that at the beginning of each group. The square root of 9 is 3, we put that at the end of each group. Then we put a plus in one group, a minus in the other group. Now there's a few things we'll be able to do here to reduce it. There's a 2x plus 3 factor in the top and the bottom that we can cancel out. There's one other thing that we can do to reduce this. X minus 1 and 1 minus x are not exactly the same thing. They're opposites. And you can cancel out opposites, but when you do that, you need to put a negative sign out in front of your entire problem. So here, our simplified answer, we would have the negative of 3 times x plus 1 in the numerator. In the denominator, we would have 5x times 2x minus 3. If you would like to try the next two problems on your own, pause the video now and resume when you're ready to see the solution. For 6x plus 6, we can factor out a greatest common factor of 6, and we would have 6 times x plus 1. Our denominator there is 7. The numerator of the second fraction is 14. In the denominator of the second fraction, we have a difference of squares. Factoring x squared minus 1, we would have x plus 1 times x minus 1. We can see then that there's an x plus 1 factor in the numerator and denominator. We can also see that 14 and 7 are both divisible by 7. 14 divided by 7 is 2. 7 divided by 7 is 1. So on the top, we're left with 6 times 2, which is 12. In the denominator, we're left with 1 times x minus 1, which is x minus 1. Looking at our next problem, 4x plus 8, we can factor out a greatest common factor of 4. And we're left with 4 times x plus 2. In the denominator, we can factor out a greatest common factor of 7x. And we're left with 7x times x minus 2. In the numerator of the second fraction, it starts with 3x squared. So we'll have 3x and x. There's not going to be that many things we can multiply to get 2. It's 2 and 1 or 1 and 2. In this case, it looks like we'll have a 2 here, a 1 here. It's a negative 2, so we need 1 positive and 1 negative. It turns out the combination that's going to give us that minus 5x we need is to have 3x plus 1 times x minus 2. In the denominator, 9x squared minus 1 is a difference of squares. The square root of 9x squared is 3x. We put that at the beginning of each group. The square root of 1 is 1. We put that at the end of each group. Then we put a plus in one group, a minus in the other group. Now we can see when we're reducing it, we have a 3x plus 1 in the numerator and denominator. We have an x minus 2 in the numerator and denominator. And it looks like that's all we can do to reduce it. In the numerator, we're left with 4 times x plus 2. In the denominator, we're left with 7x times 3x minus 1.